Atomic mass. As we already know, the atomic mass of an atom is the number of particles, protons and neutrons, that are present in the nucleus of the atom. Therefore, hydrogen, which has one proton and no neutrons, has a mass of 1. If we've got gaseous hydrogen, H2, that will obviously therefore have a mass of 2 protons. Same goes with oxygen. We have oxygen, that has a mass of 16. 8 protons, 8 neutrons. If we've got gaseous oxygen, O2, that therefore will have a mass of 32. Because it will have 2 atoms, each of 8 protons, 8 neutrons, 32 particles. This can obviously be extended for when we have compounds to look at the formula and the mass of those. The formula mass is actually the mass of all the atoms present in a compound added together. This is irrespective of whether we've got lots of the same atom or not. For example, H2O. We can see there that it contains 1 atom of oxygen, and we know that an atom of oxygen has a mass of 16, therefore 16. We can see that hydrogen, there's 2 atoms there. We know that hydrogen has a mass of 1, therefore hydrogen has a mass of 2 in water. We can add these together to get water having a mass of 18, formula mass of 18. This can be done for any compound. To find the mass of sulfuric acid that we have here, we need to add all those atoms that's present together. Again, oxygen. We have 4. We know oxygen has a mass of 16. Therefore, oxygen gives us a mass of 64 present in sulfuric acid. We have sulfur. We have 1 atom of sulfur present. This has a mass of 32. Therefore, we have 32 atomic mass units of sulfur present. And hydrogen, we can see we have 2 atoms of hydrogen. These weigh 1. Therefore, hydrogen contributes 2 atomic mass units. Total all these together gives us sulfuric acid having a mass of 98. If we have a compound that's containing complex ions and there's more than one of that complex ion, we obviously, as you remember from formula, put it in brackets. So we need to work that out. You can either work that out beforehand or you can work it out after. This is the way I would look at doing it. Here we have ammonium sulfate. Same idea. We have 4 oxygens. They weigh 16 each, so therefore 64. We have 1 sulfur, weighs 32. 32 from sulfur. Now, as I said, I tend to work out what's inside the brackets first. Nitrogen weighs 14. We know hydrogen weighs 1. We have 4 of them. So inside the brackets, we have 18. We know we've got 2 ammonium. This will give us an overall formula mass for ammonium sulfate of 132 atomic mass units. The reason we look at balanced equations and formula mass is it allows us to do something. It's very powerful, and it allows us to change qualitative chemistry, which is what's there, into quantitative. This is very powerful. it allows us to start thinking of things industrial wise, as to not just what we're going to make, but how much of it we're going to make and how much of other chemicals we need to make it.